Problem number 21. In this question, we have to solve a 15 sub-questions. So I'm going to make 4 videos for this question. So in the first part of the video, I'm going to solve the first 3 questions. So let's read what is given in the question. In given figure, where V23, which is equal to 4V1, n moles of the diatomic ideal gas are taken through the cycle with the molecules rotating but not oscillating. What are P2 over P1, and the B is P3 over P1, and the C part is T3 over T1. Let's see the given figure. So what is given in this figure? They represent 3 curves which form a cycle. From point 1 to 2, the pink curve refers to isothermal. What is isothermal? Isothermal refers to constant temperature. And then from point 2 to 3, which refers to isochoric, that means it's a constant volume. Which is, so in this point 2 and 3, there is no work done. And then from point 3 to 1, which is refers to the adiabatic curve, which is green in color. Now, we have to answer all these 15 questions by using this figure. So here, first I'm going to solve the first 3 parts. So let's write the given first. What is given in this question? They mentioned the gas is the diatomic. What is that? Diatomic gas. So for the diatomic gas, we are going to use this curve for solving all these things. For that, we need something. So what is that? If it is a constant volume and constant pressure, then we need the value of Cp and Cv, right? So the Cv value for this diatomic is 5 over 2 times of R, and then the Cp value is 7 over 2 times of R for diatomic gas. Not only that, by using this Cp and Cv, we are going to find the gamma value, where gamma, which is equal to Cp over Cv. So when you divide 7 over 2 times of R over 5 over 2 times of R, so this R get cancelled. Likewise, this 2 is get cancelled. So here gamma value is 7 over 5, which is equal to 1.4. So we need this gamma. Why I just calculate this gamma? Because we are going to use this gamma value when we are going to solve the adiabatic part. Clear? Okay. So now let's start with the first question. What is given in the first question? P2 over P1. You can see here P2 and P1. That means the pressure at point 1 and pressure at point 2. So that means from point 1 to 2, it refers to the isothermal. So let's write the given first for the first part. So in the first part, what we are going to do? We are going to find P2 over P1, which is we are going to find. So here from the graph, from point 1 to 2, the curve refers to isothermal. The curve refers to isothermal, right? So isothermal means the temperature is constant. That means the temperature at point 1, which is equal to temperature at point 2. That means T1, which is equal to T2. Clear? So now I'm going to use the ideal gas equation. So let's write the ideal gas equation for the point 1. So we can write P1 V1, which is equal to N or T1. Likewise for point 2, P2 V2, which is equal to N or T2. So let's take this is equation number 1 and this is equation number 2. So what I am going to do, we are going to find P2 over P1. So I am going to divide second with first. That means divide equation 2 by equation 1. So you will get P2 V2 over P1 V1. First I just divide the left hand side, which is equal to N R T2 over N R T1, and this is isothermal, so T1, which is equal to T2. So this will get cancelled, and here also everything will get cancelled. So now what I'm going to do, I'm going to keep pressure one side, I'm going to move volume other side. So based on that, P2 over P1, which is equal to V1 over V2. Now for V1 and V2, I have to take the value from the curve. You can see V2 and V1 we need. You can see V1, the value here is 1 because in the question itself they gave V23 is 4 times of V1. That means if you see at point 1 it is V1. So that means we can just see each and every place. That means V1, V2 and V3. So you can see it is V2 and 3 is 4 times of V1. So that means at point V1 we have only one V1, right? So now, and then likewise at point, that means V of 2 takes the value of 4 times of V1. So that means here we have to write V1 which is equal to 1 and V2 which is equal to 4 times of V1. So now I'm going to substitute the value. So P2 over P1 which is equal to V1, we have to take 1 and this is 4. So that means 4 multiplied by V1 is 1. So we can write 1 over 4. So we got the answer P2 over P1 which is equal to 0.5. So this is the answer for the first part. In the second part, we have answer for P3 over P1. So P3 over P1, you can see here P3 and P1 comes from the adiabatic curve. So that means when you are going to solve from point 3 to point, that means the pressure at point 3 and pressure at point 1, we have to use the relation between the pressure and volume. So what is the relation between pressure and volume? Part B, P3 over P1 we are going to find. So point 3 and 1 refers to adiabatic curve, which is adiabatic, and here, sorry, adiabatic. So here we are going to study the relation between pressure and volume. Clear? So what is pressure and volume equation? We studied PV which is equal to constant. That means PV gamma which is equal to constant. Am I right? We studied the theory. So what I'm going to do, I'm going to apply this rule for point P1 and P3. So based on that we can write P3 V3 gamma which is equal to P1 V1 gamma, and I'm going to separate pressure one side, volume other side. So if you write like that, we will get P3 over P1 which is equal to V1 over V3. So here gamma and here also gamma. So we can write this term as V1 over V3, the whole power gamma. So right and left hand side we have P3 over V1. Clear? Like again we have to take what is V1 from the figure they gave. V1 which is equal to 1, V2 which is equal to 4 times of V1. So I have to substitute the value. So V1 takes the value of 1 and V3, that means V2 and 3 it is 4 times of V1 which is given in the figure. So that means point 2 volume is 4 times of V1 as well as point 3 the volume is 4 times of V1. Clear? So here V3 is 4, so 1 over 4, and then the gamma value we already found from the first part which is 1.4. So here after I use my calculator, I got the answer for P3 over P1 which is equal to 0.144. So this is the answer for the second part. Now we have to answer for the third part. So here we have to write T3 over T1 we have to find. So now again point 1 and 3 from the curve, again we have to go back to the figure. You can see point 2 and 3 refers to the adiabatic. So we are going to study the relation between temperature and volume. Again we are going to use the adiabatic curve because why? In the number they mentioned T3 and T1. So again point 3 and 1 refers to adiabatic part. So this time we are going to study the relation between temperature and volume. In the theory we studied TV gamma minus 1 which is equal to constant. So based on that I am going to apply that rule here. So T3 V3 gamma minus 1 which is equal to T1 V1 gamma minus 1. So now I am going to separate temperature one side because we have to get the answer for T3 over T1. So T3 over T1 which is equal to V1 gamma minus 1 over V3 gamma minus 1. So now we can write the right hand side as V1 over V3 the whole power gamma minus 1. Again V1 from the figure which is 1, and V23 is 4 times of V1. So V1 takes the value of 1, and V3 is 4 times of V1. So 1 over 4, and gamma value is 1.4 minus 1. So here we got the right hand side. This is T3 over T1. So 1 over 4 times of 0.4. So here I got the answer for T3 over T1. After I use my calculator, I got the answer here as 0.574. So this is the answer for this question. That's it. Thank you.